Okay, let's look at this next example. We again have a c that's negative. We have a negative 10. So we've already done positive 10. So looking at negative 10, we could have negative 1 and 10, 1 and negative 10, negative 2 and 5, or 2 and negative 5. And I'm looking for the combination that adds to be a negative 9. And it happens to be the second one. Once you find it, we can stop. And so I can now factor this. Again, my first variable is x squared, so I have an x and an x. Always check that variable. And then we said the two factors are 1 and negative 10. So a positive 1 and a negative 10. And those will multiply to be negative 10 and add to be negative 9. So that's factored. Okay, let's look at this next example. Example 3, we have 2x squared minus 6xy minus 8y squared. So remember, the first step always is to see if there's a GCF that you can pull out. And I can pull out a GCF. So I'm going to go ahead and do that before I even try and factor this. So the GCF is a 2. That's the only thing they have in common. So I'm going to pull that 2 out. And remember, that means I'm going to divide everything by 2. So this is going to become x squared minus 3xy minus 4y squared. Okay, so notice there's a y squared in here. So the only difference is going to be when I'm going to draw my two sets of parentheses. Make sure your 2 is out in front. My first terms for x squared, I'm going to have x and x. And then the only difference with this y squared means I'm going to have not only my number, but I have to have a y here. So I have a y times y will give me that y squared in my last term. Okay, so let's go ahead and look at our factors of negative 4. So now that I've dealt with that y, remember I'm looking for two numbers that multiply to be negative 4 and add to be negative 3. So the only way you can multiply to be negative is if you have to have opposite signs. So I have 1 and negative 4, negative 1 and 4, and then for 2, one of them is negative. And the one that adds to be a negative 3 happens to be the first one. So I have a positive 1, so I don't need to put the 1 in front of the y, but you can, and then a negative 4, and that is factored. And you can see how in the middle terms I have negative 3xy, that if I FOIL this, so remember my outside terms, this is outside in FOIL. Okay, oops, what am I doing? I would have a negative 4xy, and then my inside terms, I would have a positive xy, which adds to be this negative 3xy. Okay, so that's where that comes from. Okay, so let's do the same thing with this fourth example. Again, we have to pull out the GCF first, which is an n. So I'm going to pull out the n, and I'm going to divide all my terms by n. So I'm going to get n squared plus 3n minus 18. So that's the first step. Now I need two numbers that multiply to be negative 18. So again, it's negative, which means my signs are going to be opposite. So I'm going to have 1 and negative 18, negative 1 and 18, 2 and negative 9, negative 2 and 9, 3 and negative 6, and negative 3 and 6. And I'm looking for the combination that adds to be a positive 3. And usually, again, it's towards the bottom where the numbers are closer together, since that's such a small number. And it happens to be this last one. These two combinations add to be a positive 3. So I'm going to factor this. Remember, the n stays out in front. Draw our two sets of parentheses. My first term is n squared, so I need an n and an n. And then the two numbers we said that multiply to be negative 18 and add to be a positive 3 are a negative 3 and a positive 6. Remember, multiplication is commutative, so it doesn't matter in what order you write these two terms. You could write it either way. Okay, let's look at this last example here. X squared plus 2x minus 3. So I'm looking for two numbers that multiply to be negative 3. 3 is prime, so my only option is either negative 1 and 3 or 1 and negative 3. And it's the first one that adds to be that 2 that I needed. So I'm going to factor, draw your two sets of parentheses, put your x, and we said it's a negative 1 and a positive 3. And that's it.